Hello, my name is Victor Kang and I'm a junior at Yale University majoring in molecular biophysics and biochemistry. Today I'm really excited to tell you about my research project that I'm conducting at Dr. Scott Strobel's lab at Yale. Dr. Scott Strobel conducts a course at Yale called Rainforest Expedition and Lab. I was part of this course in 2012 and together with my classmates we traveled to Ecuador during spring break to collect samples to research over the summer. From these samples, we isolated what we call endophytes, which are endosymbiotic microorganisms, often fungus, that live inside plants and could potentially give very interesting compounds. From the plant samples that we collected from the rainforest, we isolated endophytes such as this and this. As you can see, it doesn't quite look like your typical fungus, but these organisms, as mentioned earlier, can give very interesting properties. This one, which I have labeled as E11224A isolate, or as sequencing is shown to be Fusarium solanine, this fungus produces many volatile organic compounds that can be useful for biofuel research. My research project involves the isolation and characterization of an enzyme produced by E11224A. This enzyme is believed to use fatty acids as a substrate to synthesize volatile organic compounds called methylketones. Methylketones are common in nature, produced by many organisms, from bacteria to plants and insects. These compounds are also high-energy hydrocarbons that burn cleanly, making it a promising alternative biofuel. Interestingly, E11224A was isolated from a plant, Faveliae cordifolia, whose seeds are burned by natives in the Amazonian rainforest for light. Maybe the natives knew something about the burning potential of methylketones. I use a special instrument called a gas chromatography mass spectrometer to study methylketone production by my fungus. This is a very sensitive method of detecting compounds, and I can use this instrument to verify the activity of my enzyme of interest. What really excites me about my research project, and what really drives me to lab every day, is this project's real-world applications. Whether that be in the pharmaceutical world, in the fragrance industry, or the flavor industry. This decarboxylase enzyme could one day be used by scientists to help create compounds that are useful in many aspects of our lives. What I'm really interested, however, is this enzyme's use in biofuel research. It would be wonderful to see this enzyme be part of a cleaner, fossil-free world where it helps create alternative energy sources for transportation. Thank you very much for your time, and I hope that you are as excited about my research project as I am.